All right, this mini lesson is on the life of stars, and we've mentioned that stars form from a cloud of gas and dust called a nebula. This page gives you some terminology that you'll need to know. So, what's a nebula? What does main sequence mean? What is a red giant? How does it form? What's a planetary nebula? What's a supernova? And what's a neutron star? Okay, we'll also talk about dwarf stars and different sizes of stars, and we'll talk a little bit about that more in the next slideshow as well. Okay, before we talk about where the stars come from and that sort of thing, we need to talk a little bit about where the stars get their energy. And they get it from what's called atomic fusion. Under extreme temperatures and pressures, when you think about a pile of rocks sitting on top of you, it weighs a lot, so there's a lot of pressure on you. In the center of a star, the amount of material is astronomical. And the weight of all of that stuff, the gravity, the pressure is tremendous, and so there's very, very high heat and very, very high pressure, and it's hot enough and energetic enough that it can actually squeeze together the nuclei of atoms. Now remember, when we studied the atom, how big the atom is compared to the nucleus. The nucleus takes up about, what, 1/10,000th of the entire atom. Well, there's so much pressure and energy that it will actually squeeze these nuclei together to make bigger atoms. So for example, 4 hydrogen atoms can be squeezed together to make a helium. Right? The helium atom has 2 protons and 2 neutrons. So basically what happens is 2 of the protons from hydrogen are transformed into neutrons. And so you get 4 hydrogen atoms squeezed into becoming 1 helium atom. And when it does this, there's a tremendous amount of energy that's released. Now, you've probably heard of this equation here, E equals mc squared. And what it means is that any mass that is lost in this is converted into energy, and we have to multiply it by the square of the speed of light, which is a really, really big number. So, just to put it into perspective, if we take 1 gram of hydrogen gas and we convert it into helium, it will release 6.5 billion joules of energy, or the other unit of energy we looked at was kilowatt hours. That would be 182,000 kilowatt hours. That's enough to, power your neighborhood for a good long time. And so that's 1 gram. Stars convert hundreds of millions of tons of hydrogen to helium every second. So the amount of energy that is released in the core of a star is incomprehensible. Okay, so that's how stars are powered. So in order for a star to be born, the conditions have to arise for that fusion to begin. And we said previously that stars are formed in clouds of gas and dust that are called a nebula. Nebula is the Latin word for cloud. These gas clouds are mostly hydrogen, but they contain other elements and dust and silicon, oxygen, iron, and stuff like that. So this is one such cloud. This is the Orion Nebula. And if we magnify this image, we can see that there's little spots in here where there are actually solar systems forming, stars forming inside this giant cloud of gas and dust. So even though this cloud of gas and dust is very kind of diffuse and very sparse, it's not, it's basically a vacuum, but there's just so much of it, so much stuff occupying such a large volume that it has gravity. And what happens is there's so much stuff there that has gravity that it starts to kind of clump in spots because of that gravity. And that's when stars begin to form. So if there's a clump that starts to form, that kind of gets more mass, which then has more gravity, which then brings more stuff in, and eventually it starts to heat up because of all the stuff piled in, and we call that a protostar. So it's kind of an embryo star, if you will, which will eventually become a star. And what happens is, the more stuff builds up on it, the more gravity it gets, the more stuff it pulls in, and as it pulls it in, it starts to spiral like like water going down a drain. Because of that spin, as the material is going inwards, it actually flattens out into a disk, and that disk is what's going to become the system of planets and asteroids and so on around the sun. And that's pretty much why our solar system is a disk, is because the stuff spiraling in flattens out. The whole process takes over a million years to actually get enough material in there for the sun to start fusing and produce enough heat to become a sun. This is an artist's rendition of a forming solar system. So we have a protostar in the center that's just igniting, so it's just starting to fuse hydrogen, and it's releasing tremendous amounts of energy. And here is this disk of gas and dust kind of spiraling around that protostar. So as more and more stuff piles in, it gets bigger and bigger and bigger and bigger, and eventually there's enough mass and enough gravity that it squeezes that center in to the point where it can start fusing hydrogen, and at that point it's technically a star. Okay, so I have a video here. Where are we? There we are. And I've got a link to this, but this is kind of just a cool video that illustrates, this is a computer simulation really of what goes on in one of these gas clouds, and you can see how the material is kind of drawn in and stuff begins to swirl around, and any of those little yellow dots I think are protostars forming, and it's really quite dramatic. Now all of this, of course, remember, as we said, would take place over millions and millions of years, so this is a giant ballet that takes place on astronomical timescales. So we can see that there's some small stars forming and some big stars forming. And this goes on. And we can see how the stars form in clusters too, in these clouds of gas. Anyway, I'm not going to show the whole video now. You're welcome to watch it at your leisure. I'm going to pause it there and actually just continue on with this.